Alright, so this is lesson 151. We're going to continue graphing exponential functions. We'll have to still describe the end behavior that we talked about on Friday. So I'm just going to get us going here. Those were the answers. Here we go. So I'm going to show you numbers 1 and 2 one more time. Okay, so on this first one, we have f of x. F of x is equal to negative 2 times 3 to the x, okay? What's a equal to here?
Negative 2.
A is equal to negative 2. What's b equal to?
3.
3, okay? And I just want you to know when you see your a, this is going to be your y-intercept. I don't know if you remember that from Friday, but this is your y-intercept. Okay, we're going to make a table just like last week. And we're going to do negative 2, negative 1, 0, 1, and 2. Okay, and then we're going to think about what number, or what happens to our function when we input these values, okay? So we're going to start with the first one, negative 2, our input negative 2. 3 to the negative 2 is, what's 3 to the negative 2 from last Friday?
Negative 9.
No. 1/9, remember?
1/9. 1/9.
Good. 1/9 times negative 2 is negative 2/9, okay? Then we're going to put negative 1. 3 to the negative 1 is 1/3. 1/3 times negative 2 is negative 2/3. Then we have 0. 3 to the 0 is 1, right? Because anything to the 0 power is 1. 1 times negative 2 is negative 2. We're going quickly here. 3 to the first is 3. 3 times 2 is, or 3 times negative 2 is negative 6. And then last of all we have negative, or 2. So 3 squared is 9 times negative 2 is negative 18, okay? Then we're going to plot these points here. These are going to be ordered pairs. I'm going to plot the points. And then I noticed that the graph actually goes down, in this case, forever from left to right. So this is a negative exponential growth, meaning it's exponentially growing, but negatively as x gets bigger. So let's talk about end behavior. As x gets bigger, y approaches negative infinity. Does that make sense, everyone? As x gets bigger, y approaches negative infinity. Okay. And then look at our y-intercept. What's our y-intercept on our graph, everyone?
Negative 2.
Negative 2. Eyes up here. What is the y-intercept, everyone? Good. What's a equal to? Do you all see that connection there? Okay. Damien, you see that connection? Yeah? Okay. Number 2. Same thing. What's a equal to on number 2?
Negative 3.
Good. What's b equal to?
4.
Good. What is the y-intercept?
Negative 3.
What's the ratio of this function?
4.
Good. Okay. Just like on number 1, the ratio is 3. It's increasing by a third. We're multiplying each one by 3. Okay, here we go. So let's make I'm going to make an XY table on number 2. Okay. And I'm going to start plugging numbers in. Okay, put negative 2 in. What's 4 to the negative 2? What's 4 to the negative 2? Okay, 1 over 16. What's 1/16 times negative 3? Negative 3/16. That's right. Okay, then we have negative 1. What's 4 to the negative first? 1/4. 1/4. Good. 1/4 times negative 3?
Negative 3/4.
Good. Negative 3/4. Next, 0. What's 4 to the 0? 1 times negative 3?
Negative 3.
Good. Next is 1. What's 4 to the 1?
4.
4 times negative 3?
Negative 12.
Good. Negative 12. And then we got 2. 4 squared? 16 times negative 3?
50.
Nope. So 16 times negative 3 is negative 48. Okay. Now I want you to know it's okay for you to use a calculator. I want you to use it to help you start memorizing the larger calculations. Okay. At first I didn't know what 16 times 3 was when I was your age, and then I used my calculator and I started memorizing. Oh, I was like, oh, that's right. 16 times 3 is 48, right? Or what's 15 times 3?
45.
45. That was easy, right? Because there's 15 minutes in an hour, right? 1/3 hour is 45 minutes, right? So then 16 times 3 is just 3 more, right? Okay, cool. So then watch me finish this problem. I'm going to graph it, plotting my points, and then again, this is exponential growth, right? Not decay. Exponential growth, but it's negative exponential growth, meaning it's negatively growing. Okay. So my end behavior is as x approaches infinity, y also approaches infinity. Okay. That makes sense, everyone? Okay, cool. All right, so that's number 1 and 2. All right. So if you're on the video, take a moment to pause if you need to write this down in the steps. Put a couple more in your notes. So let's get your notes going here. Let's have you all write down number 3 here. I want you to write down the function, okay? And we're going to work this out. I'll start you off and then you'll finish up. Okay. You should have started with this. We got a is equal to negative 3, b is equal to 3. What's our y-intercept on this one? What? Good. And we can even plot that. You see right here I plotted it already because I already know this is going to be a point. Okay? So make an XY table. And I'm going to give you about a minute to fill this in, okay, with your group. What is this XY table? The values of it are. So you should start with the negative 2, negative 1, 0, 1, and 2. Okay? Fill in the table. When I have an input of negative 2, what's the output on this graph, everyone? Huh? Negative what? What number?
Negative 3 over 9.
Good, and negative 3 over 9 as simplified is? Negative 1/3. Good. That's okay if you put negative 3 over 9. Raise your hand if you got negative 3 over 9. Somebody did. Good. That's right. Which is just negative 1/3, right? Okay, next one. What about negative 1? What's the output when you have negative 1? Good. Negative 1. Right, because it's like saying negative 3 over 3 is negative 1. What about 0? What's the output? Good, that's the easy one, right? Because what's the y-intercept? Ah, do you see the connection there? What did you multiply negative 1, or what did you multiply negative 1/3 with to get negative 1?
Negative 3.
No, just 3, right? What's negative 1 times what is negative 3?
3.
Negative 3 times what is the next one? Negative 9. What's the ratio here? What's B? 3, right? Y'all see how they keep going? Yeah, it's awesome. You kids are doing it, right? Now turn to your neighbors, tell them, is it exponential growth or exponential decay? What do y'all think, exponential growth or decay? No, it's exponential growth. So it's negative exponential growth. It's not, remember you read it from left to right. Is it growing positively or growing negatively?
Positively or negatively.
I think we get confused with exponential decay because remember exponential decay is when we take things in half, right? What's 4 divided by 2?
2.
2 divided by 2?
1.
1 divided by 2?
0.5.
1/2 divided by 2?
1/4
divided by 2?
1/8.
You see how each of my answers is getting closer to 0, but it's not touching it? Okay? Good. All right. So, end behavior. As x gets bigger, what's happening to my graph? It's approaching what?
Infinity.
Negative infinity. Good job. As x gets bigger, it approaches negative infinity. Excellent. Okay, next one. Let's have you write down the problem here. I gotta stop scratching my bug bite. Okay, so f of x is equal to 0.5x. What's a on this one?
1.
1. Where'd you get 1 at?
0.
Where'd you get 0?
It's not.
There is no A.
Oh, yeah.
Should there be an a right here?
No.
Well, there
There's
should
no A.
There,
so it should
okay,
be
so when there's no coefficient here, what number can we assume is there?
1.
A 1. So a is really, a is 1. That is what you said.
You
Good.
messing with me?
No, so good job. Matthew has gotten 2 answers correct. He said growth a minute ago, and now he said 1. I just want to make sure everyone got that. Did you all see how we got that? Matthew got it. Good job, Matthew. Let's give this.
No, it's
Please give
not.
this
Stop.
video a thumbs up for Matthew.
Give the video a thumbs up.
Yeah.
we have to go and like it.
You gotta go like it.
7 thumbs up.
What's your channel? I'm gonna report it.
It's Mr. Rink Math. Report it to what?
Report it to YouTube.
Yeah, you should. Show them how awesome our class is. Okay? Here we go. So the next one. What's our B? What's B? Okay, what? How would you write 0.5 as a fraction? 1/2. Good. So remember just now I asked you what's 1/2 of 4? Good. What's 1/2 of... No, 1/2 of 4 is? 2. Half of 2? Half of 1? Good. So what? Are you predicting exponential growth or exponential decay here?
Exponential decay.
Excellent. Okay, so our A here is 1, B here is 1/2, and then we're going to start off with our XY table. Now this is going to be a little confusing, but I'll help you out on this one, okay? Okay, remember on the last one? Remember on this one I said, eyes up here. What's 3 to the negative 2? What's 3 to the negative 2 again? No, don't worry about the negative 3. What's 3 to the negative 2? 1/9, right? Don't you flip it and square it? Right? Remember that? 3 to the negative 1 is?
1/9.
No. Oh my god.
Oh, 1/3.
1/3, good. 3 to the
I
negative
got
1
that one wrong.
Okay. So all I'm doing when I have a negative exponent is I flip it and I do whatever the number is, right? Square it or to the first. Okay, so look in here. If I have this one here, I'm going to flip it and square it. So here we go. Ready? Eyes up here. So what's 1/2 to the negative 2? Remember, flip it and square it. So when you flip it, what does 1/2 become? 2 over... Good. So what's 2 squared? What's 1 squared? What's 4 over 1 equal to? 4. Good, 4. And then what's 4 times 1? 4. Good. Okay, so it's 4, right? Okay, let's do this one. What's 1/2 to the negative 1? Flip it and then put it to the first power. How do you write 1/2 as a flipped fraction?
2 over 1.
2 over 1. What's 2 over 1 to the first power? 2. Oh. Right? Next one, what's anything to the 0 power? 1. Good. Hey, what pattern do you see? What's 1/2 of 4? What's 1/2 of 2?
1.
Do you see up here? What's 1/2 of 1?
0.5.
Isn't that supposed to be 1/2 here? And then 1/4, right? And check this out. I'm going to plot these points. Let me finish and I'll answer your question, okay?
16.
Right? And good, Tommy's getting it right. If I put a 3 here, what do you predict the next number should be? The output.
1/8.
Good. If I put a 4 here, what should the output be? Good. Do you all see that? As the numbers get larger, are my fractions ever going to touch 0?
No.
No, they're always going to get half as close. What's that called when you get close to a number but you never touch it? Asymptote. Excellent. Okay. Okay, eyes up here. What's the y-intercept on this one?
1.
Good. What is a equal to?
1.
Good. You all see that?
Yeah.
Next, what is this? Exponential growth or exponential decay? Good. Do you see on number 3 here? This was exponential growth. You all see that? Is this the same thing as, even though it's going down, is this the same thing as this exponential decay here? No. You see that? Okay. What about the end behavior? Is it, as x gets bigger, what's happening to my graph? As x gets bigger, what's happening to my graph? It's approaching our asymptote, which is x, or which is what? 0. Y equals to 0. Okay. Okay, that's it. All right, so that concludes the lesson.